Welcome to another KhaliTutors tutorial session. In this tutorial session, we'll be looking at powers. I'll take you through a brief introduction of what is meant by powers, then we'll look at some of the laws, and lastly, we'll look at some examples. What do we mean by a power? A power is the product of multiplying a number by itself. A power is represented with a base number and an exponent. The base number indicates what number is being multiplied. The exponent, which is a small number written above and to the right of the base number, indicates how many times the base number is being multiplied. Let us look at an example of a power. The number 2 to the exponent 3 is a power. The base number indicates what number is being multiplied. In this case, the base number is 2, which is in green. The exponent is 3, which is in red. The exponent indicates how many times the base number is being multiplied. The above example tells us that there are 3 2's that are being multiplied. That is, we have 2 times 2 times 2. Okay? Let us look at the common terminology. While the number 2 to the exponent 3 is a power, there are some ways in which people use to refer to 2 to the power exponent, 2 to exponent 3. The first one is they can say it's 2 to the exponent of 3, or they can say 2 to the power of 3, or they can say 2 raised to the power of 3. Okay. Let us now move on to look at some of the laws that are related to powers. Law number 1 says that if we're multiplying powers of the same base, we simply add the exponents. In this case, if you're multiplying a number with a base a and an exponent m by a number with a base a with an exponent n, then the product of this is equals to a m plus n. Okay, so if you look at this, the first thing that you need to look at is the bases. If the bases are the same, okay, then what's next? Then you simply add the exponents. In this case, our bases are a. Okay, as you can see, since the base is the same, then you add the exponents. Okay, so let us use numbers to illustrate this. Let's say you've got 2 numbers. Okay, you've got number 3 to the power 2 multiplied by 3 to the power 4, and then what's the answer to this? You can see these two have the same base. The base is 3, then we simply add the exponents. Then you'll have something like this: 3 to the power 2 plus 4, okay, which is equals to 3 to the power 6. Okay, so this rule is not really strictly confined to only 2 numbers. You can have 3 numbers. For example, if you had 3 to the power 2 multiplied by 3 to the power 4 multiplied by 3 to the power, let's say, 7, you will still do the same. You're multiplying powers of the same base, you add the exponents. You'll have 3 to the power 2 plus 4 plus plus 7, which is equals to 3 to the power this is 11 to the power 13. Okay, as long as the bases are the same, you simply add the exponents. It doesn't have to always be 3. It can be any number. The base can be any number. Okay, let's say in another example, you've got 2 to the power 3 multiplied by 2 to the power 2 multiplied by 2 to the power 1. Then your answer will be 2 raised to the exponent 3 plus 2 plus 1. Okay, then your answer is gonna be 2 to the power 6. Okay, so that's basically what rule number 1 is saying. Okay, let us look at rule number 2. Okay, this rule says that if we're dividing powers of the same base, we simply subtract the exponents. It is important to note that we are subtracting from the exponent that is found in the numerator. Okay, so make sure that you don't do the opposite. Doing that, you'll get a wrong answer. Okay, so what does this mean in terms of numbers? Let us use examples. Okay, so if you've got if you've got a number 3 to the power 3 divide by 3 to the power 2. Okay, the answer to this is going to be 3, which is the base, which is the same. Make sure that the bases are the same. Don't do this for any number. Okay, if the bases are the same, that's when this rule is applicable. Then you're gonna have 3 raised to the power 3 minus 2, and then this will give us 3 to the power 1, which is basically 3. Okay, so make sure that you subtract from the exponent in your numerator. If you were to do the opposite, let me show you what is going to happen. If you were going to do the opposite, you will have you'll have your 3 raised to the power 3 over 3 raised to the power 2, and then you will have something like this. You will say 3 raised to the power 2 minus 3. Then this will be 3 minus 1, and this will be is equals to 1 over 3, and this is not equals to 3. You see, this is a wrong number. So make sure that when applying this rule, you subtract from the exponent found in your numerator. Okay, so let's do another example. Let's say maybe you've got a number 4 raised to an exponent 7 divide by 4 raised to an exponent 3. Then you will have something like 4 to the power 7 minus 3, and this is equals to 4 to the power that's 4. Okay, then that is basically what rule number 2 is saying. Okay, let us move on now to law number 3. Law number 3 tells us that if you've got a number a raised to an exponent m, which is enclosed in brackets raised to an exponent n, to get rid of the brackets, you simply multiply the exponents, and then what you will have is gonna be a m multiplied by n. Okay, so let us use numbers to explain this law. Okay, this law tells us that if you've got a number, for example 3 raised to the power 2, which is enclosed in brackets raised to the power 4. Okay, to get rid of these brackets, you'll simply multiply the exponents. You'll have the same base, which is 3, then 2 multiplied by 4, and in this case you'll have 3 to the power 8. You see, there is a difference, a huge difference between this law and the first law. The first law, we were simply adding the exponents, right? Here we are simply multiplying. Okay, so let's use another example. Let me change the color. Let's use another example. This is example 1. Example 2, let's say you've got 4 to the power 3 enclosed in brackets to the power 2. To get rid of the brackets, you simply multiply the exponents and keep the same base. Okay, then you'll have 4, then 3 multiplied by 2. Okay, so that's basically all that we have to discuss in regards to exponent law number 3. Okay, let us look at exponential law number 4. This law tells us that if you've got the product of numbers a and b enclosed in brackets raised to the power m, to get rid of the brackets, you simply multiply the exponent of a by m, then after multiply the exponent of b by m to get a to the power m multiplied by b to the power m. Okay, so let us use numbers to illustrate this law. Let's say you've got a number 2 multiplied by 3, which are enclosed in brackets, raised to the power 4. The law tells us that to get rid of the brackets, we simply multiply the exponent of 2 by 4, and then after multiply the exponent of 3 by 4. In this case, the exponent of 2 and 3 are both 1. Okay, so it's like you have something like this, which means what we have now is 2 to the power 1 multiplied by 4, okay, multiplied by 3 to the power 1 multiplied by 4. Then the answer is 2 to the power 4 multiplied by 3 to the power 4. Okay, so this case we have the power of 1, but it shouldn't, or it is not necessary that the power needs to be 1 in order for this law to be applicable. You could have had a situation where you had 2 to the power 2 multiplied by 3 to the power 4, all enclosed in brackets raised to a power of 4. In this case, you use the same principles. This will give us 2 to the power 2 multiplied by this 4 here, okay, multiplied by 3 to the power 4 multiplied by 4, and then this will give us 2 to the power 8 multiplied by 3 to the power 16. In most cases, in exams or assignments, you will find such questions in terms of like variables. You'll be given variables like y to the power 2 or z to the power 3, all enclosed in brackets. Let's say in brackets raised to the power 2. And then if you're given a situation like this, you use the same principles. You will have y to the power 2 multiplied by 2, okay, z to the power 3 multiplied by 2, and then this will give us y to the power 4 multiplied by z to the power 6. Okay, so that is basically it when it comes to exponential law number 4. Let us look at the last exponential law. Okay, so this law says that if you've got a number a divided by b enclosed in brackets raised to the power m, to get rid of the brackets, you'll simply multiply the exponent of a with the exponent m and the exponent of b with the exponent m. In this case, the exponent of a is 1. Okay, the exponent of a is 1 and the exponent of b is 1. Therefore, you'll have a to the power m over b to the power m. Okay, so let's use numbers to illustrate this law. Okay, this law says that if you've got two numbers, which is, for example, 2 over 3 enclosed in brackets raised to a power, let's say 4. Then to get rid of the brackets, you simply multiply the exponent of 2 or with this exponent here. Then that will be 2 1 multiplied by 4. Okay, this is multiplied by 4, divide by 3. Okay, 1 multiplied by 4. Okay, and then your answer will be 2 to the power 4 divided by 3 to the power 4. Okay, so this case here is a special case. Okay, it's not always going to be the case that you have the number a raised to the power 1 or the number b raised to the power 1. Let's say we've got a case where the power is not 1. Let's choose blue. Let's say we've got a case where the power is not 1. For example, let's say we've got a number 4 divided by 5. Okay, 4 to the power 2 and 5 to the power 3, all raised to the power, let's say 4. Okay, in a case like this, you will simply have to multiply, let's say this is 2, you'll simply have to multiply these two exponents. Okay, then you'll write the base 4, okay, and then have 2 multiplied by this 4. So this 2 comes from here and this 4 comes from here. Okay, you do the same for the denominator. You'll have 5 3 multiplied by 4, and your answer will be 4 raised to the power 8 over 5 raised to the power 12. Okay, that is basically everything that we have to cover so far with regards to these laws. Okay, I'll give you more information about other special cases or identities as we continue studying. Okay.